In today's video, I will be solving a problem based on moment area method for a simply supported beam. Simply supported beam. So now here this is a simply supported beam where a point load is acting at the mid of W. Let it be W, and this from this point to this point, let's consider as L. This is the length. Okay, so now in case of moment area method, the first and foremost step is to draw the bending moment diagram. So now bending moment diagram for a simply supported beam where load is acting at the mid will be like this, like this. Okay, it be WL by 4, and this is the bending moment diagram. And after that we have to draw the M by EI diagram, where if EI is not given in the question, not given, then we have to keep EI only, okay, as a constant. Now we have to draw the M by EI diagram, so it will be same as bending moment diagram, like this, where WL by 4 we have to divide it with EI, so this will become M by EI diagram. Okay, and last step is to draw the elastic curve. So elastic curve for this type of beam will be like this, right? And here at the mid there will be a maximum deflection maximum, and at A, let it be this point as considered as A, and this point as B, and this point as C. Okay, A, B and C, this also A, B and C. Now at C point there will maximum deflection will be there, and at the A and B the maximum slope will be there. Okay, so it's nothing but the elastic curve. Now from this method, from moment area method, we have to find the slope and deflection. Now first we'll start with the slope. So now slope, we have to apply the first theorem to find the slope, and slope is denoted by this term theta. Okay, so here we know that as this load is acting at the mid, so see, if we divide this term, this part will be equal to this side, right? So this theta at A will be equal to theta B. Okay, so now to apply this theorem, by applying this theorem, what we have to find is theta value, slope will be at the two side, that is theta A and theta B. And always remember, this is the important thing, okay? And I have also mentioned in my previous video also that at the fix there will be, the slope will always be 0, but at the hinge or roller support there will be a slope. So now as this is a simply supported beam, so slope will occur at point A as well as at point B. Now what happened, we know that theta A is equal to theta B, and what was the formula? Area of M by EI diagram. Okay, now where is M by EI diagram? This is the M by EI diagram, right? So this diagram is the M by EI diagram, and from here, from this diagram we have to find the slope. So now what we have to do, here we have to draw an imaginary line, and we have to find the area of this part, because we know that this part is equal to this part, right? So if we solve this part, we can get the value for this part as well. So now what is the formula? It's a triangle, right? Half into h into b. So now half into h is this, right? This is nothing but what? W L by 4. W L by 4 E I into base. Base will be, the whole length was L. So half will be L by 2 and L by 2, right? So it will be L by 2. So if we simplify this, we'll get the value WL square by 4 1 over 4 2 8 8 2 16 EI. So here theta B is equal to WL square by 16 EI. So we know that theta A is equal to theta B, right? So you can write like this: theta A is equal to theta B is equal to WL square by 16 EI. So this is the value for slope. Now second step is to find the deflection. This is the deflection. We have the value for this theta A and theta B. Now the next step is to find the value for deflection, maximum deflection. So we have to apply second theorem, and second theorem is for finding the deflection. Okay, deflection, and this deflection term is denoted by a delta or this delta. Okay, we can use either. Now we know that to find the, I'll use this delta. Okay, now to find the delta value, what was the formula? Moment of M by EI diagram at suppose B. Okay, now moment is nothing but area into CG distance. Now what was the area? We have to find for this term is half into h into b. So the area will be half into h is WL by 4 EI, right? So WL by 4 EI into the distance was from here to here is L by 2 into L by 2 into, so as I have already mentioned the here, okay, we have to find the CG distance. So now for this triangle, the CG will act at the center. So it was B, right? And this was C. So here what I have written is moment of M by EI diagram at B. So we are starting from this B. So from this B to this CG distance is 2/3 of the L. And if we are coming from this side, then the value from here to the CG will be 1/3 of L. So now as we are considering from the B side, then we have to consider this length, okay, into 2/3 of L. So we'll get the value here after simplifying, that is WL cube by 48 EI, and this is the value for maximum deflection. So here this is the value for theta A and theta B, that is the slope, and the deflection value is WL cube by 48 EI. Okay, so in my next video I'll solve some other problem based on moment area methods. Thank you.